All right, today we're going to talk about something called the determinant. You guys already know how to do this, so it's going to be easy. All right, you use the determinant to solve equations, which we're going to do in 11.5. It's another way to solve equations, and it does, in some cases, make things a lot easier. So this is the determinant, right? You use the coefficient matrix. We'll talk a little bit about that in a second. So but here's your determinant. Does this look familiar? If this was A, B, C, and D, your determinant is A times D minus B times C. Isn't that what we used to find the inverse? Yeah. So that's the determinant. When they talk about the coefficient determinant, we're going to talk about this next when we come back from spring break. But say we have this. I don't know, negative x plus 3y equals 1. And you had to write the coefficient matrix. It's the numbers that are the coefficients of the variables. So it would be 3, -1, -4, 3. We'll talk about that more later. But all we're talking about with determinants are 2x2s and 3x3s. The 2x2s are real simple. The 3x3s aren't any harder. It just takes an extra step or two. So this is another way that you can that you can label a determinant like this, where it says DET with an A or a B or whatever in parentheses. I'm just going to ask you to give the determinant, find the determinant, that sort of thing. So if we're going to find the determinant here, again, this is what we had to do for inverse. Remember, we had to multiply A times D and then B times C and subtract them to find the number that goes in front. This is exactly what we're doing here. So to find the determinant, you would say A times D, which is 2 times 2, minus -3 times 1, right? What's 2 times 2? 4. Minus a -3 gives you what? 4 minus a negative would be plus, so 4 plus 3 is 7. So your determinant value is 7. It's always going to be a number, just one number. Could be positive, could be negative, could be 0, but it's just going to be one number. So in this case, this is a 2x2, so you're going to find your determinant. It's A times D, so 2 times 2, minus B times C, so 1 times 4. 2 times 2 is 4, minus 4. What's your determinant here? 0, okay. And then the last one, okay, you have a fraction, no big deal. Still the same thing, A times D, so 0 times 4, minus B times C, so 3 over 2 times 4. What's 0 times 4? My bad, thank you. What's 0 times 4? 0. Minus, you can look at this two ways, guys. You can cross out the 2's, just make it a 3. Or you could say 3 times 2 is 6, and then 6 divided by 2 is 3. Same thing. So 0 minus 3 is -3. Everybody see that? All right, so when you have a 2x2, finding the determinant is exactly the same thing that we did with the inverse, to find the inverse. When you have a 3x3, it's a little bit different. Is this on your notes, this part? Okay, so here are the rules for a 3x3. Okay, you can't really just say, okay, here and then you go. It doesn't work like that. With a 3x3, you have to do the following. You have to recopy the first and second column. Then you're going to identify the 3 major and the 3 minor diagonals. And you're going to multiply and add, and then we're going to subtract. Watch what we do. First thing we do, recopy the first 2 columns. So I'm going to say out here, 0, 3, 4. And then I have 2, -1, 0. Everybody with me? Now, before it was A times D, so top left to bottom right, correct? And then minus B times C. Same concept. You're going to have 3 majors. So we're going to say right here, 1, 2, 3. By recopying the first 2 rows, you create the 3 new majors. So what you do here is you multiply and add. So this first one right here, what is 0 times -1 times 1? 0 times -1 times 1. 0. Plus, what's the second one? 2 times 2 is 4 times 4 is 16. Good. And then the third one, what's 1 times 3 times 0? Perfect. Then you have a big minus sign. And now we're going to identify the 3 minors. So we're going to say these ones. 1, 2, 3. And we do the same thing. What is 4 times negative 1 times 1? Negative 4, good. And then you have 0 times 2 times 0, 0. And then 1 times 3 times 2, 6. And now we simplify. In yellow, what's 0 plus 16 plus 0? 16 minus, what's negative 4 plus 6? Positive 2, right? So then what's 16 minus 2? 14. And there's your determinant. Now you guys are like, oh, why do we have to do this? Remember, matrices is another way to represent a system of equations. So this right here is an actual system of equations. It's 3 letters, 3 variables. And what we're going to do is you're going to have a system of equations, and instead of doing that Gaussian elimination where we multiply the first and second eliminated x's, first and third eliminated, that sort of thing, you're going to use matrices and the determinant to figure out the solutions to equations. It's really kind of cool. So let's do 2 more, and then we're done. All right. Is this a 2 by 2? No, it's a what? A 3 by 3. So in order to find the determinant of this 3 by 3, what's the first step? Recopy the first 2 columns. So I'm going to recopy. Make sure your signs are right. So 3, negative 1, 4, and then 0, 2, 5. Everybody with? All right. So now we're going to identify our 3 major diagonals. Major would be top left to bottom right. So 1, 2, 3. Try to keep all my colors together. So that first one is 3 times 2 times 1, which is 6. My second one is 0 times, does it matter? No, what's 0 times anything? Good. And then the last one, what's 1 times negative 1 times 5? Negative 5, perfect. So what goes in the middle between these two? A minus sign, good. Now let's identify our 3 minors. It's this, this, and this. So I have 4 times 2 times 1. 8, good. 5 times negative 6. Negative 30 times 3. Negative 90. And then I have 1 times negative 1 times 0. 0. So now let's simplify. Inside our parentheses first, what's 6 plus 0 minus 5? 1. Minus, what's 8 minus 90? Negative 81, perfect. Signs are real important here, guys. If I have 1 minus a negative 81, what is that the same as? Plus, so my answer here is 82. Perfect. Good. Huh? Oh, yeah, it is 82. You're right. That's okay. I'm just going along. This is negative 82, right? So it's plus the negatives. This is 83. Thank you. I'm just as bad, Antonio. I just like, All right, last one. Let's do the last one, then we're done. It's a 3 by 3. So what is the first step? Recopy what? The first and second column. So you have a 4, negative 7, 9. And then I have 0, 1, negative 3. So let's identify our 3 majors. Top left, bottom right. Top left, bottom right. Top left, bottom right. Top left, bottom right. Multiply. 4 times 1 times 2. 8. 0 times 5 times 9. 0. 1 times negative 7 times negative 3. 21. Perfect. What goes in the middle? Minus sign. That's very important. And then my 3 minors, my little ones. So I have 9 times 1 times 1. 9. Negative 3 times 5 times 4. You can do this either way. What would be easiest to do? 5 times 4? 20? Times negative 3? Negative 60. Good. And then 2 times negative 7 times 0. Yep. And now we simplify. What is 8 plus 21? What is it? 29, right? Minus, what is 9 minus 60? Negative 51. Guys, if you have minus a negative, what does that become? Plus. So what's 51 plus 29? 80. And that is your determinant. So when we come back after spring break, right, we are going to use this concept to solve equations, and it's called Kramer's rule. It's really easy. We're going to do that on Monday when we come back, and then we're going to go over our tests or our quizzes. We're going to review, and we'll take our matrices tests, 11, 1 through 11, 5. We'll take it like Wednesday, Thursday when we come back from spring break. All right, so good. It's pretty simple chapter, not too bad of a lesson. So there you go. I'll upload it now.